Hello everyone. My name is Mohammad Jalili. I'm a graduate student here at UNL for computer science field, and my presentation is about chain of thought in large language models. So first of all, my original paper that I'm going to present to you is named as Chain of Thought Prompting Elicits Reasoning in Large Language Models. It's a great paper and a famous paper, and it was published in NeurIPS Information Processing Systems conference, which is a prestigious conference, and it was published by 2022 by Wei and his colleagues. So, as you know, large language models are a breakthrough in both academy and industry, and I'm sure all of you have used many large language models like Gemini, like ChatGPT, and so on. So we can skip that because of the time. So, although they are very great at many jobs, and they have revolutionized natural language processing, but they struggle with complex reasoning when we input some complex prompts for them. So, usually when we are using LLMs like ChatGPT, we are using standard prompting. So what is the standard prompting? If you open ChatGPT and you enter some kind of prompts and you expect some outputs without having any intermediate steps, this is called the standard prompting. So as an example, if our prompt is something simple like put a pear sink in the water, the output would be correct and it would be no, it would not sink. But most large language models, except the famous ones, will fail when we are giving them some complex tasks, and they have some limitations for understanding what we really mean. So take this example. If John has 5 tennis balls, he buys 2 more cans of tennis balls. Each can have 3 tennis balls. How many tennis balls does he have now? So we know the answer is 5 plus 3 times 2, which is 11. But the model will incorrectly say the answer is 10. So this is the limitation of the models. So as one of the techniques that we can use in order to resolve this problem is chain of thought. So this is a prompt engineering technique that increases the reasoning ability of the LLMs. So it encourages the model to have some kind of step-by-step reasoning in order to reach and get the final answer and get the correct answer in the end. And the experiments and results that we are going to present to you shows that it improves accuracy for complex tasks and for longer outputs. And also another advantages that we are going to discuss is that it makes the output of the model more interpretable. So for the same prompt that we got the incorrect answer, if we somehow make the model generate an output like this, which has a couple of sections, and it ends up with the correct answer, we are doing chain of thought. So the goal of this paper is to make the model generate some kind of step-by-step reasoning inferences in order to get to the answer, which is right, which is 11 at the end. So before discussing what the paper is going to do, chain of thought is bringing us some benefits. The first benefit is it breaks down the complex problems into intermediate steps. And this will lead us to have some kind of interpretability benefits, which will be helpful for debugging because we can understand at which point of inference the model makes mistakes. Although this is not guaranteed to be 100% correct, but this can help us in some way. And the experiments show that chain of thought can be applied to any kind of task that can be explained by language. So for example, mathematics, logics, and common sense that we are using in this paper. And the experiments that we're going to use, to discuss in the next slides, show that the real power of chain of thought will be shown when the number of parameters for the model is more than 100 billion parameters. But it's not guaranteed. So if the model has less number of parameters, chain of thought is still beneficial. So the paper that we're going to discuss has 3 types of problems that it's going to discuss and resolve. The first is arithmetic, which is some mathematical problems that is going to be resolved by chain of thought. The second is common sense, which is some general purpose problems, not like arithmetic, which requires mathematics, and not like the next category, which is symbolic reasoning, which requires a lot of reasoning behind it. And the models that was used in this paper are 3 models. The first is Lambda, the second is GPT-3, and the third is Palm. And for each type of problems, they have used a couple of benchmarks. So you can see the name of the benchmarks. I'm not going to name them one by one, but the most important one is here for common sense. They have used a benchmark for data, which is a temporal benchmark. And the second one is secant benchmark, which is a benchmark for robotic tasks. As a baseline of these experiments, they are going to show that chain of thought performs better than the standard prompting with few-shot learning or few-shot prompting that one of the guys before my presentation has presented to you. So because we are going to use to show chain of thought is better than standard prompting, our inputs can be something like this. You can see that there are a couple of tuples here. Each tuple has an input and intermediate steps for chain of thought, and also the output that is expected. And for the last tuple, we are inputting some new input, and we expect the model to generate a chain of thought and output. So here are a couple of examples for each kind of problems. You can see that the green examples are related to arithmetic, the orange examples are related to common sense, and the blue ones are related to symbolic reasoning, which is divided into 2 subcategories. The first is last letter concatenation, and the last one is coin flip. All right, so after conducting these experiments, they have divided the results into 3 types of problems. And for the first one, which is arithmetic reasoning, here is the results. So you can see the horizontal axis will show the number of parameters of the model, and the vertical axis will show the accuracy of the model or solve rate. And we have 3 columns, which is for each column is for one model. So you can see how chain of thought has, outperformed the standard prompting. But to be deeper inside the, results, we can see that chain of thought will show its real power if the model has more than 100 parameters. But if it has less than 100 billion parameters, it is still, gets good results. And so our results so the results of the paper shows that chain of thought performs well for complex tasks. And also for the last 2 columns, which is GPT and Palm model, you can see that the model sometimes outperforms the supervised fine-tuned models. So it shows that to get a more accuracy, we don't need to necessarily have supervised, fine-tuned models. We can also use chain of thought if the model has a great number of parameters, like over 100 billion. And regarding the common sense reasoning, here is one of the diagrams that was discussed in the paper. It's using Palm model. You can see that chain of thought performs well, and one of the notes in this diagram is that, like the previous one, the model performs well for the first 2 benchmarks, where it performs better than the supervised fine-tuned models. And for the date and secant datasets, which are for temporal and robotic datasets, the chain of thought shows that it can be used. So this is a great technique for these 2 datasets. And lastly, for the symbolic reasoning, problems, chain of thought is still better. But to be more detailed, you can see that for out of distribution tasks, the standard prompting is almost 0. So standard prompting performs very bad, very poor, but the chain of thought performs very well for in-domain and out of distribution. So if I'm going to discuss what is in-domain and out of distribution, so as I said, we are providing the model with some few-shot prompting examples, and at the end, we pass the final input. So if the number of steps in the examples that we pass to the model is equal to the number of steps that is expected for the model to have in the output, this is called in-domain. If the example that we pass has is simpler than the input that we are passing to the model. This is called out of distribution. The next keynote here is that so chain of thought works well for both in-domain and out of distribution. And an interesting note here is that for the PAL model, when we are using chain of thought, sometimes the accuracy can be 100%, near 100%. And this is showing the real power of chain of thought. So regarding the insights that we get from this paper, first of all, we showed that chain of thought substantially enhances multi-step reasoning accuracy, and it shows that to get a good accuracy, we don't need to necessarily fine-tune the model. We can just have some prompt engineering. And another insight is that the gains and the benefits of this methodology is not limited to just longer outputs or larger models. As we saw in the previous diagrams, the chain of thought is still better when the number of parameters is less than 100 billion. But as I said, the real power of the chain of thought is when the model has more than this number of parameters. And one of the important limitations that exists in the real world researchers is that chain of thought can have wrong reasoning and get the correct answer at the end, or the reverse direction, which the reasoning is correct, the reasoning is wrong, but the final answer is correct. So this is a limitation of chain of thought. So there is no guarantee to get the good and correct answer. And another limitation that many researchers suffer is that we need a benchmark or a data set for passing to the model when we are using few-shot prompting across the chain of thoughts. And this is a limitation because there are no much data sets in the internet or anywhere, so we can use for chain of thought. So in a nutshell, there's a trade-off here. While chain of thought is powerful, its practical deployment requires requirement engineering also, and it's significant computation because the model requires to generate more output and it requires more resources to compute. So as a conclusion, we said that a chain of thought is a simple yet powerful prompt engineering technique. And the paper that we tried to briefly discuss is Chain of Thought Prompting Elicit Reasoning in Large Language Models, and published by Wei and his colleagues. And we showed that chain of thought across 3 LLMs and 3 types of reasoning, and each problems that we discussed had their own specific benchmarks, more than one benchmarks. And we showed that chain of thought improves our reasoning accuracy for all the problems that we discussed. And as a final note, chain of thought is powerful, but it depends on model scale or number of parameters, and also the quality of the prompt that we should generate before passing to the model. So thank you so much. If you have any questions, please let me know.
Yeah, okay, thank you.